All right, good evening, everyone. I hope you're all doing well. Please, can you see my screen?
Yes, please.
All right, so we are going to continue from where we ended last Friday. Last Friday, we ended at the conditional statement, and based on that knowledge that we had, we were able to write at least some kind of conditional statement for that section of the activation function that we've come to appreciate. That's a good thing because depending on the new knowledge we get on new things that we learn, we are also going to expand to make our work look a little bit better. So today we are going to start with the Boolean operators. And in this particular chapter or section, as I prefer to call it, we are going to take inspiration from some few things over here. So now when we talk about the Boolean operators, it is almost like the Boolean algebra or the logic gates that we know. That's the whole concept. So over here, we know that in Boolean algebra or logic gates, we have the AND gate, we have the OR gate, we have the NOT gate, we have the exclusive OR, exclusive AND, and we can make a whole combination out of that. Now, the inspiration we are taking is, well, we can have two conditions and we can OR it or we can AND it. In a sense that we can have, let's say, condition A and condition B to do something if and only if it is an OR. If it is an OR, then it means either condition, once it evaluates to true, then we are okay. If it is an AND, then what it means is both conditions needs to be true before we can get an output of true. So in order to get this going, let me just show you this. What I have over here is I have three quotation mark. Okay, this something referred to as a doc strange. Okay, a doc. Let me doc strange this way, and we can also use this for commenting because the CPU will not execute this. So we are going to have something like an OR gate over here. And if this was a typical class session, I'll probably would ask you to draw this for me. But then let me just put it out over here. So let's say we have two inputs, X1 and then X2 as the input, and we are expecting a Y. If this is a typical OR gate, then what we expect is, let me just copy this, Control C, bring this down so that we have the inputs. So for our inputs, we can start with 0, 0, then we'll do a 1, 1. Or yeah, then over here we'll do a 0, 1, 0, 1. Let me just make things a little bit clearer. All right. So these are the inputs, and based on our knowledge on logic gates, we know that, okay, if this is an OR gate, then this is more or less a false. It's also a false. So the resulting output is going to be a false. So over here, we expect a 0 over here. If this is a false and this is a true, because at least one of them is a true, we get the result or the output as a true. The same thing applies over here. One at least is a true. So over here, the result is going to be a true, and over here too is going to be a 1 because both of them are true. That's the concept you are trying to build over here. And if it is an AND gate, then definitely both of them needs to be true before we get a true. And for which reason? The rest or the other combinations are going to be false. So based on this, let's see how we implement things in code. And like I said, we may have two conditions. And one of the examples I use quite frequently is, let's say on the Ghana electoral roll.
Ken, sorry, 1 minute. Please, are you recording for them?
Yes, I'm recording.
Thank you.
Okay. So for instance, on the Ghana electoral roll, you have to, I think, needs to meet at least some three basic conditions. So first of all, you need to be a Ghanaian. You also have to be 18 years or above before you can get onto the electoral roll. And also you have to be of sound mind. So these three conditions are a matter of and. So all those conditions needs to evaluate as true before you can go and register. If you are Ghanaian, but then you are 15 years old, you cannot be on the electoral roll. If you are Ghanaian and you are 15 years, you are 20 years old, you are Ghanaian, you've met two conditions. But if, excuse me to say, for some reason, you are mentally retarded, okay, then definitely you can also not be on that electoral roll. So now let's look at a typical example in the context of some of the things we are learning. So let's say we have age is equal to 20, and then height is equal to 40, and then gender, let me make this male this way. Okay, so now I can say that let's say this person maybe meets the criteria for something that we are trying to do. Okay, so the person needs to be 18 and above, a height of let's say 40 something or above, and the person needs to be a male, maybe security service recruitment or something. Okay, these are the requirements they have in there. You need to meet all these before you are selected. So over here we can see that, okay, if the age is greater or equal to 18, we can say print you are qualified. So you are qualified is showing up over here. So I ran this and we are getting you are qualified, because indeed the age we have over here, it is set to 20, and this age is actually greater than or equal to 18. But then if let's say the age is 2 years old, then I don't get anything over here because I haven't written any condition to cater for that. So maybe I can say else and I'll bring a string over here and say you are not qualified. So currently as it stands, it's going to print you are not qualified as we see over here. But then if age is 20, then in that case, this condition is met. So you are qualified. But then this is where the and comes in. And over here, let's just say we are doing an and gate. So let me change this to and. And of course, the combinations or the output over here is going to change, because over here is going to be 0. Over here too is going to be 0. For the AND gate, both conditions needs to be evaluated as true before it works. And then over here too is going to be 0. It is only when both conditions are true that we get a true statement over here. So over here, look at this. We are saying that, okay, if your age is greater than 18, and for instance, and your gender is equal to male, then because we are using the AND gate, we are going to say we are qualified. So now if I run this, everything is working out over here. You are qualified. But then if the gender was a female, then in that case, yes, this is going to evaluate to true. That's almost like this condition we have on line 11. The first input is going to be true, but then the second input, in this case, gender, is going to be female. In that case, that's going to be a false. So the result of an AND operation between these two conditions is going to be you are not qualified, because both has to evaluate as true before we get that going. So now when I run this, it tells me you are not qualified. So that's basically what we use this and OR gates for. Okay, but then if I'm to do an OR over here, then what we have over here on line 17, this currently as it stands, this condition is going to be a 1. So it's almost like the one we have on line 11. This is a 1. And this condition is going to be a 0. So 0. But then because it is an OR gate, either of them, once one evaluates to a true, we expect to see this one over here. This combination, if it is an OR gate. And I believe you know these OR gates, so definitely I'm not going to spend a lot of time over here. But then that's a concept that I want you to understand. So because this is an OR gate, and even though this is evaluating to a false, so far as we have one true statement over here, then it is going to say you are qualified. So now when I run this, you are qualified over here. Now, we can rather make this a little bit look cool, in a sense that this is what I tell students. Try and put all your conditions in brackets this way, so that in the mind of Python, because it also has that BODMAS order of precedence, anything in a bracket will be, evaluated exclusively from each other, so that you don't have any problem. Because the more you have some of these conditions and you are mixing things up, it may get a little bit messy. So it is still going to work because we are using OR gate over here, but then we are just being very cautious and being pragmatic on making sure that we don't run into problems later on. So that's just by the way. And of course, the NOT gate is rather going to negate everything, okay? So yes, originally this is going to be a true statement, so I'm going to get this printed out. But then if I'm to negate not everything over here, so in that case, it is the entire thing I'm notting, okay? Then it is now going to print you are not qualified because I've inverted it. This is like the inverted NOT gate. So that's just by the way. Now, these are the logical operators, and then also we are saying that the Boolean operators, we use them to combine with the conditional statements as we are seeing over here. So these are some of the conditional statements, the if, the else, and all those things that we spoke about last week. Now, there's also something we call the membership operators. So in the membership operator, we use the keywords in, not in. Okay, so the in is to check if something is in there, then it is probably going to evaluate to a true or a false. Then there's the not in, to evaluate if something is not in something. So let me just comment these ones out and show you or demonstrate that with another example. So let's say I have the variable we have been using quite frequently, school, and I'm saying University of Ghana. This is a string. And we know that in this string, we have at least words like University of and Ghana. So the question I want to ask Python is, Ghana in school. I'm asking, is the string Ghana in the variable school? So like I said, this is going to evaluate to either a true or false. And clearly we can see that, yes, we have Ghana in school, okay? So when I run this, we get a true statement over here. It is pretty much, yes, sir. It is pretty much intuitive to appreciate this, because this is almost like an English statement. We are asking, is Ghana, the string Ghana in the variable school? And this is very clear. But then if I'm asking the question, is Legon in school? Clearly, the string we have over there contains University of Ghana. There's no Legon in there, okay? So when I run this, we get a false over here. Now back to the Ghana example. And this is what I tell students all the time. When I do Ghana as we have it over here in school, what do you think is going to be the output? Anybody can help us with an answer.
False.
Okay, it's going to be false. And can you give us an explanation to your false?
Okay. It's false because Ghana, for the variable school, the Ghana in there has starts with capital G.
Okay.
But in the print statements, the Ghana in there is small g, and
Small g.
Python is case sensitive, so
Thank you.
it's going to be an error
Okay.
or false.
Thank you very much. So when we run this, we do get a false over here because once again, Python is case sensitive. So whatever thing we're searching is not exactly as we have it over here. So that's with the membership operators. So now that's with the in, okay? Now we can also kind of negate this by asking the opposite of that question. So I can say Ghana not in school, okay? And clearly this one is going to evaluate to a true because Ghana is not in school. The question I'm asking is Ghana as we have it over here not in school, and the answer is true. Now, if I'm to do a capital G, then over here is a false. I'm trying to say Ghana is not in school, but Python is telling me that false because the Ghana as you currently have it is actually in school. So that's basically the membership operator. As we move on to other things, we are going to bring some of these things back. And then we have another one we call the identity operator. And this is an interesting one. We want to check the identity of some variables and some things that we may later run into. So now look at this particular example. Let's say I have 10 over here, and then I have y is equal to 10.0. So this is a little bit, not too much of an issue. But then the first question I want to ask myself is using this logical operator over here, okay, or the comparison operator to check if the value I have in x, which is 10, is equal to the value I have in y, which is 10.0. I mean, on a face value, they are the same. Is that okay? 10 and 10.0. Well, we can have a whole long argument about this if we are being very biased with our engineering principles. Definitely 10 can never be equal to 10.0. All right. But then if we are to use this comparison operator, it tells us that that's the case. Okay. But then if I'm to use this keyword is, the question I'm trying to ask is x is exactly the same in terms of everything around x, the same as y, then over here, I'm going to get a false over here. Because over here, it's actually beyond the magnitude of that values you are trying to compare. It is also checking for, I mean, the very nitty-gritty data type and other things over here. So definitely in terms of identity, they are not the same. But perhaps maybe in terms of magnitude, we can be a little bit loose on that. But now look at something very interesting. If I'm to do this, clearly, if we are not being very critical, we can definitely say that, well, this value you have over here in terms of y, the decimal point you have over here is so insignificant to cause y to be anything greater than, how do you call it? The one we have in x, okay? But then let's use the identity operator. Initially, when it was 10.0, it was telling us that they are true. I mean, it is the same. Is that okay? Sorry, it is false. So now when I run this, it is still telling me that it is false. But over here, when I come back to use the comparator operator to check, like I said, this is so insignificant, but at least there is some one over here which is causing a change, okay? So clearly when I run this, it is telling me that, what do I see? Okay, it's telling me that it is true, they are the same. Let me see something like this. This time around, it is telling me that it is a false. So, I mean, you get the point. If it is too insignificant, it tells you that it is not the same. But then if it is very close, it kind of tells you that. So this one is telling me that it is true in terms of the value. The initial one, what did I do? This one was true in terms of the value. Okay. Then once it gets a little bit smaller, then at least this one is quite significant than the other one. So this one is telling me that it is a false. So it is very sensitive to some of the decimal values that you may have moving on. Okay, so now let me just move on to the last one we have. Okay, so that's it with the is and not is, or the is not. So that's basically trying to negate whatever thing we have over there. Now let's move on to the next chapter where we are going to look at Python collections. So for the collections, we are going to start with the list. So we are saying that the Python list is a collection which is ordered and mutable. It is ordered and mutable. So these are two keywords I want you to pay attention to. So in here, we've seen variables where we've seen something like name is equal to Kenneth, okay. Then we've seen age is equal to 12. We've seen, let's say, other various different data types, okay. So GPA is equal to 4.0 and other thing. But then that's not just it, okay. These ones, probably we call them the primitive data type, okay. Those are the very primitive, the common, the very basic ones. We can actually have a collection of these data types put together as a collection. So when I say a collection, what it means is we can have a particular structure where we have, let's say, an int, a string, a float, and different data types put together. So over here, let's look at this. Let's say we have a variable called max, and max is going to be a list. So for the list, I have to use this square bracket. The moment I do this, Python knows that this I'm referring to as a list. So now let me just do a printing of the variable max as I have it over here, and also to check out the data type of max. So when I run this, clearly I get to see that, well, this is an empty something, but then we see that this is a list. So it is an empty list over here. I can now start putting in value. So let's say the first student had 90. So now when I run this, I see that now the list is being populated with values. But like I said, it could be maybe another one had 80. So currently the values I have inside of this list are all integers. So everything looks great. They are all integers. It is still a list. And it doesn't matter if I now end up, maybe somebody gets a 78.5. Clearly this 78.5 is a float, a different data type from the integers we've seen in 90 and 80. But then if I put this one over here, it is still a list. So regardless of the data type we put in there, the most important thing is these square brackets we use to specify that this is a list. And like we dealt with the strange methods and all those things, list will also have its own methods, own functionality that applies to just list alone. Now we are saying that they are ordered and they are mutable, and it also allows duplicate members. So the moment I say some of these things, please take note, because we will get to other versions of collections that will also have different characteristics. So once again, I can do another 90 over here. Definitely we have 90 in here and we have another 90 over here. So we are getting some duplicate values. But then when I run this, it shows up that yes, I have 90 and I also have another 90 over here. Now, let me also add a string. Let's say Ghana. Then maybe true, which is a Boolean. Then maybe 3 plus 5J, which is a complex, okay? And we can go on and on and on. But the most important thing, it is still a list. Like I said, the most important thing to identify a list is this square brackets we have over here. Okay. Now, you may not have lists showing up this way because normally we want to put things in groupings that actually make sense. So having 90, 80, 78.5, another 90, Ghana and other things is not really the thing, okay? But then let's just maintain this. So we know that, yes, it can contain duplicate members. Now let's see the order over here. Now, earlier on, we saw something like name is equal to University of Ghana. And we came to an agreement. We actually said this, that, well, each character in this range has an index position. So for instance, character capital U has an index position of 0, then the N will be 1. It goes on and on and on. And we can, even without counting, confidently say that the A at the end is going to be a -1. That is uncontested. Good. Now, the order over here also matters in the sense that, well, there's an order over here. And the order is like that the first element we have over here also has an index position of 0. And each element is going to be separated by a comma. So 90 is going to be 0, then 80 is going to be 1, then 78.5 is going to be 2, then the last 90 over here is going to be obviously a 3 or -1 if we decide to use negative indexing. Now, the very things we learned with when we're picking up a specific value and also slicing, let's say, getting university out of the entire thing also applies over here. So in principle, we are just transferring knowledge from that place to this place. So now let's see a typical example. If I'm to do a printing of max over here, okay. If I run this, clearly I get this, okay? But remember, we used to do something like this when we're dealing with string. So for instance, if I pass in an index of 0, what it means is I just want you to grab that first element I have over there. So when I run this, I get my 90. If I pass in an index of -1, let me do this 900 and then another 90 over here. So now let me do an index of -2, which is going to be the 900, okay? We get our 900 over here. An index of -200. Remember when we're doing something like that in the string, we are getting something out of range. So over here too, there's an index error. It says the list index out of range. So it is quite intuitive. Some of the knowledge we learn from other places, we are applying them over here. Good. Now, once again, we can also do the slicing. Let's say I want to start from the first 90 and end at 78.5. Remember, the ending index position is exclusive. So I have to do a 3 over here. So I'm leaving the beginning blank because I want to start from the very beginning and end at 78.5, but then I have to go to the next one because this is exclusive. And indeed, when I run this, I get exactly that. So I get a string or a sub, sorry, not a string, a sub, how do you call it? A sub list, okay? From that entire list where I had other elements in there. But because I'm doing the slicing, okay? The same thing applies if, let's say, I want to start from this 2. So let's say I want to start from 78 point whatever, and what am I doing? Okay, 78.5, which is the index position 2. The index, the first, the starting index position is inclusive. So maybe I want to start printing from here and everything. I can do it this way. And that's exactly what we see. Let's say if I want to do from here to end here, then what I need is, okay, I need a starting index position of 1 and an ending index position of simply -1, okay? So when I do a -1 this way, everything is going to show exactly as I want it. So like I said, all those things apply over here too. Now, there's something I also want to show in that we can actually grab, because lists are mutable, okay? When we say something is mutable, that means it can change, okay? The mutability, it can change. So I can say, for instance, max and pass in index 0. When I say index 0, what I mean is, okay, now I want to take that index position and, for instance, assign the value, and this time around, let me be very obvious, assign the value 5,000. So because of the mutability, now later we are going to see that other data types, this is not going to work. If I'm to do a printing of the max, because on line 5, I have mutated the first index position, and now I'm putting 5,000 over here. Now, the new list has taken 90 off because that was that index position, and I've done a mutation of that value into 5,000 over here. And then it continues with the rest as we have it over here, showing up in here. So that's with the mutability. Now let's move on to other things because there's a lot to discuss on list. So over here too, we can use the len function, just as we're dealing with the len function in strings. That was basically to calculate the total number of elements we have in that container. That same principle apply over here. So I can do a len and pass max over there. And then if I actually want to see it, I have to go and grab or use the services of the print function. So I don't really have to count this, but then I get a 5 over here because this is the first element, this is the second one, this is the third one, the fourth one, and indeed the fifth one over here. So we can also apply the len function over here. And of course, like I said, these lists will have their own methods. So these methods, once again, you cannot apply them on strings because strings are different things altogether. So now let's see. We can use the append method, and this one will add an element to the last or to the end of the list. Currently, as we have it, the end of this list occupies or has 90 over here. Now, if I'm to do max.append and pass in some kind of a value, so the value I want to have over here is 600. And if I'm to do a printing of max this way and run this, clearly we get to see that 600 has been appended or has been added to the last element over here. So clearly that's the inherent behavior of this append. But then there's also another one we have over here, which is, let me see. If I'm to do max dots, there's another one. So there's append, there's very good, there's insert. So with the insert, let me comment this one. With the insert, we definitely would want to insert an object, okay, before index. So we specify the index position. So let's say this time around, we don't just want to append, because the append by default is going to put it at the last element. But let's say I want to put it at index position 2. This is 0, this is, this is 0, this is 1, this is 2. So I want to have, let's say, the 600 in between this, so that one will take the index position 2. So when I do insert, I'll specify the index position and the value I want to put out over there. So this time around, I want to put 600 inside of that second index position. So now when I run this, clearly we get to see that, yes, we now have 600, not just appending. Appending will put it at the last index position, but then this time we are inserting and we are specifying an index position 2 over here. So that's basically the differences between the append method and the insert method in list. And then we have some other examples over here. We can basically clear the list. So before we do the clearing, let's do the copy. So we can copy. So let's say this is the first one. This is the max, okay? And let's say I do another variable, new max over here. So I can say the max dot copy. When I copy it this way, it is going to copy whatever thing I have over here inside of this new variable, new max. So I can do a printing of the new max variable, which is a list, and run this, and clearly you see that a copy was done on max and was placed inside of this. Now I can even move on to do something like new max dot append, and this append is not going to affect the original max, okay? So if I'm to append, let's say 700,000 or 700,000. Now when I print new max is going to have 700,000 over here, but then the original max is not going to have the 700,000. So let me print that one just beneath that. The original max maintains its original values over here because I haven't applied a append method on it. It is only the copy that I did in new max that I'm specifically applying the append method on the new max. So they are completely two different variables operating differently, but then because there was a copy somewhere, there's some kind of a relationship. Then what that means is if I also come in here and change the original max, okay, I've taken the floating point value out. So clearly, because this is doing a copy over here, it is definitely going to now affect new max. So even though they are independent, but then it is also relying on the copy over here to initially populate that list. So this time around, what's happening? No, this is what I had to take off. Okay. So if I take this one off and run this, clearly that's what we see over here. So the copy is doing exactly what it's supposed to do. Now we can also do the counting over here. And just as we did with strings, we can do the counting over here to count. And then we can check the index position. I think also in string, you have something like this to check the index position. Now let me do a demonstration of this sort. So I'll do a Control-C of this and bring this over here. So we want to sort. Now, if we want to sort this, there are two ways we can do this. So I'm doing max.sort. And if I print this, this is going to sort this in ascending order, okay? So from smallest to the biggest. So clearly, we are expecting to see, let me run this. We are expecting to see an 80 before a 90 and a 90 before the 900. And that's exactly what we see over here. An 80 before the 90, another 90 and 900. Let me comment these ones so that they don't print out. So this is we sorting, okay? Now, this is the inherent or the default behavior. we can alter it. So clearly, when I hover my mouse around this, you see that we have some other parameters that we can specify. And the reverse, it is a Boolean. So if I want to reverse the order, now I want to do a descending order from the biggest to the smallest, then I need to do a reverse, and it accepts a Boolean. So it's either going to be true or false. So I'll pass reverse is equal to true. What it means is now the sorting, I want it in descending order. So now reverse the order for me. So now when I run this, now clearly we get a 990 and 90 before we get to the smaller one, which is the 80. So that's by way of looking at this. Now, there's also another interesting one over here, which is the reverse method. So this reverse method is different from the sorting. The sorting will sort it in ascending or descending order, and we can look at that variation. In the case of the reverse, it will actually pick exactly what you have and do a reversing of it. Okay, so now if I'm to do max.reverse this way, and now I print this, what it means is the max over here. What it means is it is now going to run, and I'm going to get 90, 980, and 90 in that order. And that's exactly what I have over here. 90, 980, and 90 in that order. So this one is just reversing the order in which you presented it. But then the sorting will sort it either in alphabetical or descending order. So those are the ones that we can look at, and we cannot spend a whole lot over here. But then as and when it becomes necessary with some of the things, we'll come back and look at them. Now let's quickly move on to a tuple. And tuples are quite interesting. So over here, we see that a Python tuple is a collection which is also ordered, but then it is not mutable. And it also allows duplicate members. So the difference basically between a tuple or a tuple and a list is the fact that it is a mutability issue that we cannot do. So we saw something like this. We saw Mark or Max to be 90, 80, blah, blah, blah. And when we just do a printing of Max and also checking the data type of Max, we get to see that indeed this is a list. We get to see that this is a list. Now, one of the things I said, which I'm coming back to it, is the fact that, well, as far as determining the specific data type is, the most important thing Python is looking out for is how you have declared it. So it doesn't really matter if this was declared in a double quotation mark this way. Then in this case, this is a string. Okay. If this was declared in such a way that this one is not going to work because we have more values than, sorry, we have more values than variables. But then if I'm to do mark and say age, then this one is going to look at them as independent integers that we are working with. Good. So now let's come back to this. Now, if I'm to put this in a parenthesis or this curved bracket as we have it this way, remember a list was going to be this square bracket, but then a tuple is going to be this, parenthesis as we have it over here. So it is the same value I'm using just as the list, but then this time around when I run this, it tells me that this is a tuple. And let's come back to this. So we are seeing that the tuples are ordered. So let me put out more values over here. I'm doing 100, I'm doing a 70, and I'm doing a 40. So we have a tuple of these integer values over here. It could be different data types as we did earlier. So we can have Amagana over here and stuff like that. It is still a tuple. Nothing has changed about its inherent behavior as a tuple. The most important thing is putting this parentheses around it. Okay, so now let me just get rid of this. Now, this tuple, we are seeing that it is ordered. So just as we tested the order for the list, we can also do that ordering over here. So over here, the first index position is 0. We have 1 over here. We have 2. We have 3. And of course, we have 4, or I keep on insisting, -1. So over here, if I am to, for instance, do the slicing once again and pass in index position 0, I expect to see a 90 over here because that's the order. I'm getting 90. Okay, this one is looking good. If I'm to do an index position of -1, I expect to see a 40 over here. Okay, if I'm to do an index position of -1000, I expect to see out of range. So far, everything is working. But remember, in the list, we could do this. We could do, for instance, max and say, I want to grab the first index position and do a mutation like we saw. So over there, we did a mutation like this, and we're expecting to get, I mean, if this was a list, okay, we're expecting to see that, well, now this 1000 is going to take that first index position, that's 90 is occupying, and we are going to get a return value of 1000, 80, 100, 70, and 40 if this was a list. But because this is a tuple, and the fact that this is not mutable, the values we have in here, when I run this, we get into a problem. You see that there's a type error. Tuple does not support item assignment. So we're trying to change some value in there. It was like, no. But then if this was a list, just by changing the brackets over here, then this is possible, as we did indicate earlier. So those are the differences we have over here. Now, you are going to ask, when do we use a tuple? When do you use a list? They are almost the same, but then in some instances, if you want to be very pragmatic in some of the data you are working with, you don't want instances where just a common or a very simple mistake like this can cost you a lot. So sometimes you'd want to put your things in tuple so that you are rest assured that the thing is not changing one way or the other. Okay. Then you also have some few things, some how do you call it? Some methods that we can deal with. So when I do max, which is a tuple dot, I also have, and this one, there are some few methods. Okay, so the count basically is going to count the number of whatever thing you have in there, and it has count because also it supports duplicate members. So I have 200, okay, 200 values and also 240 values over here. So clearly, if I'm to do a printing of the max, as I have it over here, that's exactly what you see, okay? And the order is also very important over here. All right, so that's just by the way of we knowing that there's also tuples. Now, there's also one thing I also want to make sure I cover, which is that we can also unpack tuples and lists and whatever thing that we want, okay? Remember, we're unpacking strings and integers and all those things. We can also apply that same concept over here. So let's say I can say input data, comma, output data is equal to, and maybe this is a list of, let's say, the ages. So let's say 20, 50, and 60. So this one, as we currently have it over here, is going to go into input data. Then I'll do a comma. And let's say this one is going to be, the output data is going to be, let's say, male, comma, female, based on maybe some data I've collected, okay? Female, yeah. So this is going to be the input data, and what we have after the comma is also going to go into the output data. So now let's see it in action. So now if I'm to do a printing of the input data and run this, that's exactly what we get for this. If I'm to do a printing of the output data, so let me do the output data over here. I'm also going to get a list of the output data I have over here. So like I said, it is the list and the tuples also work, but then it is more prudent we do it this way because we also don't want a situation where we are writing code and all of a sudden a female has changed to a male. Meanwhile, that's not our initial intention. So yes, this one is still going to work, but then in this case, then we are being very careful. Okay, so the output data is still the output data, and the input data is still going to be that input data. Clearly, if we have more of this, so let's say I have another one and do another comma over here and run this, we get that error we used to get. Okay, in that case, it says that what this one has too many values to unpack. This one is making sense. All right, so we can go on and on and on with this. But then let's quickly move on to the other collections that we have which is the set. So the set is also an interesting one over here. And this one, please pay attention. It says a set is a collection which is unordered. So this one, there's no order over here. And we are going to see a classical example over here. And it is not mutable. And it does not allow duplicate members. So the set is kind of departing so far away from the other ones we've covered so far. So now let's see how a set looks like. Now, if I'm to do, let's say, data is equal to, remember, if it is a list, I just do this, okay? If it is a tuple, I just do this. Now, if it is a set, it's a little bit tricky over here. I have to do this, but there's a but over here. Now, look at this. If I'm to print this data as I have it over there, and also print the data type of the data you are seeing over here. Now, pay attention. From here, we are going into dictionaries, okay? From here, we are going into dictionaries. But then, what I have currently over here on line 3, the declaration that I've done, if I run this, this is telling me that this is a dictionary, okay? But then, I was expecting a set. Now, basically, for the set and dictionary, we kind of use the same way of doing it, which is this curly bracket over here. But then as soon as I put in, let's say, a value, which in this case, this is an empty string, is that okay? The moment I put in a value over here, then it changes to become a set, as we see it over here. And this is an empty string. It could have been, let's say, 20. So this is a set over here. Good. So when we get to the dictionary, we're also going to see, well, the dictionary is also going to have values over there. So if as soon as I put in value, it turns into a set, then what values can I put in the dictionary? But then we are going to come there. But then please pay attention to something that I'm about to show you. So let's say I have 100 over here, I have 90 over here, I have 30 over here. So these are the values we have in this dictionary. In this set, okay? Now, pay attention because I'm going to run this a couple of times, okay? The first time I run this, please pay attention to the order we have over here. We are getting 50, 100, 20, 90, and 30. At least let's just pay attention to the first two values we have over here. So in this first run, we are getting 50, 100. When I run it again, we are getting 50, 100. When I run it again, 50, 100, run it again, 50, 100. Well, something is supposed to happen, okay? Let me see if I can use, the perfect example to use is to use this one. So let me use strings, okay? Let me use strings. And basically, let me just convert everything I have over here into a string. So even though, I mean, they are all strings as we have it over here. So when I run this for the first time, I get 30, 20, 100, 90, 50. When I run it for the second time, the order now changes 100, 20, 50. When I run it again, 30, 50, 20, 30, 90, 20, 90, 100, 30, 90, 30, 100, 100, 30, 90. So like the order is not, I mean, it's not consistent over here whenever you have sets. And that's why we are saying that it is unordered. There's no order over here. And for which reason, let me just come back to this. For which reason, we cannot confidently say that this is occupying index position 0, because remember when we were running it, it was changing. So we cannot do this over here. And over here too, one unique property of about sets is the fact that it does not allow duplicate members. So for instance, if I'm to do another 30 over here, let's say 3 30s over here, and run this, it is only going to show me 130. That's what we see over here. All right. So what I usually ask students to do whenever I'm in classes, well, okay, I'm going back to this as a list. I have this square bracket around it. And if I want to remove duplicates in a list, there's a simple way out and there's a long way out. The simple way out is we can do a typecasting over here. So remember, in some cases, we're able to convert a strange number into an integer, we can also do a typecasting over here. So if I'm to say x is equal to, and this time around, I'm going to say set and pass in data over here. All I'm trying to say is, okay, this data is a list, but then I'm doing a typecasting, passing this in a set. And because inherently, set will not allow duplicate members, it is going to drop all the duplicates I have over here. So for which reason, if I now come in here and print x over here, when I run this, it has taken everything out, I mean the duplicates out for me. And it is telling me that this is a set. If I want this back as a list, I can equally do another typecasting over here and make sure that I'm getting x back as a list. So that maybe there's a specific method that pertains to list. There's a specific method that is applicable to list that I want to apply. I can still use it over here. So the old concept of typecasting from one data type, let's say a string, into an int, we are applying that same concept over here. Now, these sets also has their own unique, how do you call it? Their own unique methods, okay? Just as we've seen with the others. So now let me say I have the first data. So let me call data 1. And let me duplicate this and do data 2. And let me just use different values. So I'm just increasing the other values I have over here. Let me do a 10. So I have data 1 containing, these are lists. Let me change them into a set. Okay, now, just as we know with sets, okay, we can do a union, we can do an intersection of sets and all those things that we know back then, okay? So now this is what I want to do. I can do, let me do this. I can do data 1, which is a first set dot, and I can do an intersection, okay, and a number of things. So you see there's a pop, there's a remove, and based on the knowledge we have from other places, we can make some inferences out of this. But then we can do a union, okay? Union of this with the data 2. So you know what the union does. The union will basically put all these sets together, okay? So, I mean, all the values we have into one big set. So now when I run this, we actually get that. So the first set just had 20, 50, and 10. But then because we are doing a union over here, it is putting the 50, 20, and 10 together with 100, 500, and 200. All right. Now we can also do an intersection. And the intersection is going to check between those two sets which values intersect or which values appear in set 1 and also in set 2. Now currently, as we have it over here, we don't seem to have an intersection yet. So now let me just do the intersection method over here. So I want to do an intersection of data 1 or the set 1 and set 2. So when I save this and run this, clearly this is an empty set. So I don't have any intersection over here. But then let's assume, let's say I had 100 over here appearing in data 1 and also 100 appearing in data. Then the intersection is going to be 100. So when I run this, I'm getting 100 over here. If I have 200 over here, it doesn't really matter if this set has more values than this one. We are just looking at the intersection, okay? So this time around, I'm getting a 200 and 100 because indeed 100 appears in data 1 and also in data 2, and also 200 appears in data 1 and data 2. So those are some of the inherent behavior of sets. And like I said, as we move along, we are going to see how we apply these ones. And we can also check the difference. And I think that one is in the video, a very simple one for that matter. Now let's move on to the last, but not the least of these collections, which is the dictionary. And with this dictionary, I tell students that, well, some of these terminologies and names are quite intuitive, okay? So just as you know with dictionaries that you use to improve your vocabulary and stuff like that, yes, that's the same concept you have over here. But then the key thing we are trying to project with regards to these data collections, especially with dictionary, is the fact that a dictionary is a collection of key value pair of data. So there's going to be a key and there's going to be a value. So normally when you open up your dictionary, the keys are probably the words you are looking for. And the value is going to be the description of those words. So for instance, the meaning of a word like, I don't know, any word you can ever think of, is going to be unique to that key. You are never going to have duplicates of words having different meanings. Yes, you can have synonyms, but it cannot be that the description of a word like pen, maybe pen can be a verb and a noun, but then we are not doing English over here, okay? Let's just look at it, I mean, in a very simplistic way. So let's say the description of the word pen, it cannot be, or it cannot hold the same description for, let's say, water or any other object we can think of. All right. So then the big question is, how do we actually do this? Now, we are also saying that it is ordered, and the mutability, yes, it is mutable, okay? And it does not, this one, it does not allow duplicate members. So please do a little bit update of the notes over here. So now let's look at the dictionary. So now let's say we have data, and we said the moment we do this, this is a dictionary by default, okay? So I can do a printing of data, and I can also do a printing of the data type of data to actually verify that this is a dictionary. And we've actually dealt with this earlier on. So when I run this, we get to see that, yes, indeed, we are working with a dictionary. But then, like we said, this is a key value pair. The moment we were putting values over here, these were just values. That's why it was making it a set. But then if it is a key value pair, then this is how we go about it. Let's say I have, and I can open this up this way so that it looks a little bit cool. So let's say I have, let's say, some kind of a structure of a data I want to maintain, okay? So let's say the data, I can have something like name, and I'll do a column this way. So this name is going to be the key, and the value I'm associating with name is going to be Kenneth. Then I bring in a comma over here. Then I want to have something like age is going to be, let's say, 12. That's the football age I use in class. And then let's say I have another key. But then clearly we could see that, I mean, let's run this and see. We get to see that, yes, indeed, we have name as Kenneth and also age as 12 over here. And it is still a dictionary. It is a dictionary now because we are now assigning the keys and the values, okay? Because a dictionary is a key value pair of data. Now, let's look at the order. Now, in the case of dictionaries, dictionaries are ordered by the keys. Dictionaries are ordered by the keys. So we saw that in the case of tuples, they are ordered by the indices. Okay, the index position is the order. In the case of list, it was also so. But then sets were unordered, so we couldn't have done any ordering over there. In the case of dictionaries, they are ordered by the key. So just as we could do, let's say, data and grab something in there. Now, when I do 0, 0 is not going to work, okay? Let me just comment this one. When I do 0, 0 is not going to work because there's a key error. It doesn't see any 0 over here. But then when I do this and pass in, for instance, a key like name, it is now going to print out whatever thing I have inside of name for me. When I put out a key like age, it is going to print out whatever thing I have inside of that key. But then with this whole key value pair thing, okay, one of the things I have to mention is the fact that, well, the keys are not always going to be these strings for the values to be strings or integers. We can have anything as a key. So for instance, we can have 1 as the key, and then I can say 1. Do another comma. I can have true as a key and do a list over here. So, I mean, I'm just trying to be over the place. So let's say a list of Python, then I have Java, then I have C++. So when I still run this, I'm getting this. And if I'm to uncomment this, it is still a list. A dictionary. Now, the key point I want to put out over here is that, well, the key can be any data type that we've learned. So clearly, you can see that the first one, the key was, for instance, a string. The second key value pair we had, the key was a string. The third key value pair we had, the key was an int. And the fourth key value pair, the key is a Boolean. And the data too. The data we associate with the keys. The first key value pair, the value was a string. The second key value pair, the value was an int. The third key value pair, the value was a string. And the fourth key value pair, it is a list. So we can go on and on and on with this. But then the point is now, if I come and do a selection of the one over here is a valid key. So it will be able to grab this and tell me that, well, this one, I was printing out. I'm taking one and I'm getting, let me see. Let me just comment this one out. I know why. So when I run this, I'm getting one over here. Okay. Now, the problem I have with this is, now, typically Python also sees these Boolean data types, 1 to be true and 0 to be false. Okay. So the reason why this was, I'm still printing or grabbing the key of 1, but then it has moved to this 1, like behind the scene, this is 1. Okay, logically, when it's evaluate this, it sees this as 1. Okay, but then if I put in a false over here and run this, I'm getting my 1 over here because that's a key value pair. But then if I'm to put in, let's say, a 0 over here, now this 0 is going to be this false. I mean, the value we have over here, if you get a point I'm trying to make. Now, this is also revealing something, and it's the fact that, well, it is mutable. Mutable in a sense that originally I have name assigned to Kenneth. If I come down here and pass in another key value pair with the same key, name, and also a value of University of Ghana, and I'm trying to grab the key name, if I run this, I'm getting University of Ghana over because of the mutability. Clearly, initially it was this. It is almost like having a variable and going down there and assigning another value to the same variable. That overwriting thing I explained earlier on, that's the same principle and concept being applied over here. But remember what I said with the one Python also sees true as 1 behind the scene. And that's the reason why when this was true, it saw that, okay, initially 1 was a true, 1 was assigned to 1 over here, this string. But then you did an overwrite over here. That's why it was printing this list for us to see. All right. We can go on and on and on with this, but then the point I want to make is these are key value pairs, and we are going to see this a lot, especially with our data. So a typical example of this is we can have something like the features, okay? So we can have features like, let's say, weight. So this is going to be a set. Let me make this a tuple so that we all know the inherent behavior of tuples. We cannot come back and change anything by mistake. Let's do a height over here, and let's do an age over here. So these are some of the typical use cases, and the values we have. We can have a whole lot of things over here. We can have a list of lists, okay? So let's say I have a list over here, and let's say 20, 50, 70, okay? But then this list is embedded in another list, in that I'm also having another list over here, and let's say 30, 50, 500. We can go on and on and on and on with some of these things. And this is some of the ways data will be presented to us. Okay, so the moment we see that, we should have an idea of, okay, this is what it means. We have data in here. We can actually select by a particular key and get that value and do whatever manipulation or computation we want to do with it. So that's just by the way. So now let's see, we can also do a copy, just as we did with the how do you call it, the tuples and the list. Okay, so that we can copy from one variable, one dictionary to another variable. We can also do the clear, we can also do a pop, and we can do the keys and dot values. So let me just show you. Now, if I'm to do this data we have over here, dot keys, and call this method, all I'm trying to say is that print all the keys for me. Currently, we just have one key, okay, which is this tuple as we have it over here. So when I run this, we get to see that these are dictionary keys, and we see this showing up over here. If I'm to say dot values, then it's going to print the values I have associated with the keys. So that's the values I have showing up over here. And this is pretty much a complex thing. Don't worry. When we start working with some of these things, it will become very simple and very clear. But then the key thing I want you to note is dictionary is a key value pair of data like you've seen. The key can be any data type. The value can be any data type. However, it is ordered, and the order over here is by the keys, unlike the list and the tuples. And it is mutable. So it is like we can override some key value pairs in there. And then it does not allow duplicate members. So the not allowing duplicate members is a little bit counterintuitive, okay? Counterintuitive in the sense that we saw a typical example of name, which was Kenneth. And we had another duplicate, which was name is equal to University of Ghana. The whole principle is if it allows duplicate members, then it will allow the same key value pair with different things. But then in this case, it is overwriting it. So the mutability works over here, but then in the strict context of allowing duplicate members, it is not working over here because each key and the value associated with it should be unique. Now we have some 15 minutes. Let me just jump into this so that the next time we meet on Friday, we'll be able to cover these last 4 chapters we have over here. And that's going to be with loops. And we are going to see some few examples what we can do with loops. Now, the whole principle about looping is when we are looping through something, some of the keywords I want you to take note of is we are iterating. We are iterating, or to be more simplistic, we are counting. Okay, we are counting or we are iterating, or so the question is what exactly are we counting? We can have, let's say, a string and do a counting of the individual characters we have over here. So we want to count them one after the other. So we can do that. We can also have, for instance, a list. And just by doing this square bracket, we know that this is a list. And we can do a counting of the values as we have over here. And through the counting, we can probably do certain things in there and bring in some of the conditional statements. So whilst we are looping or whilst we are counting these numbers, if you see a particular number, do this to that number, that kind of logic. That's what you want to do over here. Okay, so now we have basically 2 types of the loops. We have the for loop and we have the while loop. And now let's start with the for loop because that's a very simple one. So the first example we have over here is we have the variable name. So this is what I can say. I can say for, and I have to, this is the syntax, okay? So for, that's a for loop. We saying for means we are going to use a for loop. Then I can say char. This is a new variable I'm introducing over here. So for char in name. So most of the things we have said in the past is trying to manifest over here. Remember this in was a part of the, I think, part of the Boolean operators. We're looking at in over here. Very good. The membership operator, okay? So we are saying in and not in. And we are combining that with this over here. So I'm saying that for char, which is a new variable I'm introducing. So I'm saying that for character in name, So I'm going to check if there are some characters in name over here. Then I need to bring in a colon over here. Now, the moment you have colon over here, then there's going to be some indentation of some sort. So when I press enter, automatically that indentation works for me. So for instance, let me just print char over here. Now this is going to loop through this piece of string over here. But then upon every iteration or upon every counting of this looping, the first iteration, char is going to occupy, or char is going to have the value k, because k is in name. Is that okay? Upon the second iteration, char is going to have the value e, because e is in name. Upon the third iteration, char is going to have the value n, because n is in name. And it's going to print them for me, like I've specified over here. So currently this code, as it stands, when I run this, it is going to print Kenneth in this more or less a vertical order for me this way. So that's what we see over here. This is just giving us the general structure and some of the things we can do. Okay, now let's look at this particular one where we have this data over here. And this one will make a lot of sense. So let me just comment this one. We are still using the for loop over here. And what I want to have is I can say for x in data. Now x is going to be that new variable that's going to occupy those values at every position. I can simply proceed to say print, for instance, let's say x, which is then going to print these ones for me. No problem. But then I just don't want to be printing things like this. So I'm running this loop and I can put in a conditional statement over here. Let's say I want to check the number of values that are greater than 50 over here. Let's say these are some marks of students I want to check. So if it is 50 and above, that students have passed. Okay, but then if it is below 50, obviously you know what that means. So I want to check those who have passed these exams. These are the 3 students I have. So I can say that, okay, if the x, which through this iteration, x is going to occupy, the first iteration is going to be 20, the second iteration is going to be 90, the third iteration is going to be 50. Okay, so I'm going to say if that value of x is greater than or equal to 50, then I can say print that x for me. So over here, the loop is going to run upon the first iteration. X is 20. So it will come over here. That x20, is it greater than or equal to 50? The answer is no, so it doesn't print it. Then it goes on to this again. Is x greater than this 90? Is it greater than or equal to 50? Yes, it is the case. So it will print 90 over here. And then when it comes to the third example or the third value you have over, or the third iteration actually, is x, which is 50, is it greater than or equal to 50? It is not greater than, but then it is actually equal to, so it also print it out for me. And that's what we see over here. So now let's also modify this code and see, okay, what if I just want to get the exact number? I just don't want to be, how do you call it? Be giving me, it's just like maybe there are about 500 students in a class. I don't want to be seen, or I just want to maybe have some kind of statistics, maybe 20 students pass, 100 students pass, and stuff like that. Okay, so what I'm thinking of is now, okay, since we are looping and getting some numbers over here, okay, what I can do is, let's say, I can say, okay, let's say, creating a new variable. I'm just thinking about a variable name that I can use over here. Let's say, okay, let me just use new data. And this new data, I'm going to put this as an empty list as I have it over here. So now, instead of just printing this out, I'm saying that, okay, if the x through this iteration, if it is greater than this, then I can now say new data dot append. What do I want to append? I want to append x in it. which is that iteration value that we saw the case of printing X, which was 90 and 50. But now I just don't want to be printing 90 and 50. I want to append in this new data as I have it as an empty list over here. So now it is going to append some few things over here. So now let's print that new data as we have over here. So now let me print new data currently. So now when I run this, we get to see that, well, it is printing two things over here. The first one, it printed an empty string, sorry, an empty list. Then it went on to print, how do you call it? 1 with 90, and also went on to print another one with 90 and 50. And that's basically where we have this print, how do you call it? This print statement over here. Now, when I do an indentation of this and run this, it is not serving the purpose as we have it. But then look at this. When I bring this, when I bring this print out, it actually gets the exact values that were left out, okay? And I'll explain why. But then, like I said, we probably just wanted to get the total number, so we can also apply the learn method over here. So clearly you can see that some of the things we've learned, we are just putting them together and making sure that everything is looking. So now when I run this, we get to see that, okay, I have 2 people who passed out of the 3, and these were the 2 people. This is how you represent data and interpret some few things over here. So now let me explain why we had to bring this thing outside of this loop. Now, this loop is checking for every time we have an iteration, and for which reason it is going to represent, if it is first iteration, it's going to represent 20. If it is a second iteration, it's going to represent 90, and the third iteration as we have it over here. Now, we are saying that if that number is greater than 50, we are appending. So yes, we have done the appending. But then if we are printing, remember this is the original list, the new list. It is appending onto this. So if we come outside of that loop and we are printing new data, we are actually grabbing this from here. But because it has been able to append, it is like this, almost like a shadow appending over here. That has occurred. Even though we don't see it over here, but based on the logic that we have, there's appending these X values in here, and for which reason, when we do a printing of this, it grabs whatever thing we have appended, and it is now showing us over here. So earlier on, I said when we have duplicate values, for instance, when you have duplicate values, a list is going to allow duplicate values. And we can simply do a typecasting into a set to get rid of the duplicate values. Now we want to write the proper code to actually remove all the duplicates, okay? We want to write the proper code to remove all the duplicates. So now currently, if I run data or print data over here, data is going to contain everything with the duplicates. Okay, so now we can use a for loop. So I'm going to say for X in data. First of all, let me just print X so that I know that everything is working. And this is what I encourage students to do. Okay, write your code in simple incremental order. Don't lump everything together and then you get lost. So now everything is working. I have everything showing up over here. Okay, that's good. Now I have this empty list over here that I want to be appending. So now I'm going to say that if the data X not in new data, you see that it's almost like an English statement. So if X, the looping that I'm looping, each and every number, if it is not in, remember we spoke about the membership operator. So currently, if it is not in this list, then what do I want you to do? I want to do the new data dot append. What do I want you to append? I want to append X in there. And I can come back here and do a printing of new data. So upon the first iteration, it will run this. X is going to be 20. It will ask, is X not in new data? New data currently as it stands upon the first iteration is going to be an empty list. So it is not in it. Therefore, it is going to append that X inside of new data. Then it runs the second time. X is 90. Is X not in new data? Upon the second iteration, it is just only 20. That's over here. So it is not the case. So it is actually going to append 90 to it. Now it runs for the third time. X is 50. Is X not in new data? X is not in new data because upon that iteration, we only have 20 and 90 in there. And for which reason, it is going to append. Then it comes to the fourth iteration. Is X not in? Now we have 90 and it will check. X is actually in there, so it will not do the appending. So now when I run this, we get to see that now we've been able to use this loop to actually get exactly that and maybe drop all the duplicates as we have over here. But like I said, just by using a set, that's just one line of code. Over here, we have to use the loop. And I hope you appreciate some of these things over here. It's very simple for you to understand. Now, let me just quickly touch on some few things with the while loop, which I believe probably on Friday, I'll just touch on the while loop. But then there's something we can use over here, which is the range method, okay? So we can actually loop through a range. So I can say for, let's say, for number in range, and I have to pass in a number over here. So let's say 10. And if I'm to print number, all that I'm trying to say is, well, I want you to do some counting, okay? Remember with the counting starts from 0. And normally the index or the ending index position is exclusive. So over here, we are going to count from 0 up to 9 because this is the ending index position, okay? But then if you actually count the total numbers that you have, it is actually going to be 10 because starting from 0 to 9 is 10. So when we print number over here, it's going to loop through this range and give us from 0 to 9 over here. So it starts with 0 and it ends with 9, as you can currently see in the terminal. Then over here, we can...
Hello, Ken. I think we don't want to saturate them too much. So
Yes, sir.
probably when you finish the range, then we can suspend the rest so that Friday
Okay.
will continue. Otherwise, people will get a lot of things jammed, especially for the first year students.
Okay.
Okay.
Sure. Okay, so that's with the range, okay? And we can actually be a little bit pragmatic over here in the sense that we can specify a starting range, okay, or a starting position and an ending position. Remember, the start is always going to be inclusive and the end is going to be exclusive. So over here, we expect to see a counting from 5 up to 9 because this 10 is the ending. So let me just open this up a little bit and clear my terminal so that you see exactly that. So when I run this, we get to see that we are starting from 5 and ending at 9 because we always know that when it comes to counting in Python, the starting index position is always inclusive and the ending index position is always exclusive. Now we can also start from, let's say, 0, end at 10, or maybe, end at, let me do 20 over here. But then we want to have an increment of 5. So we don't just want to do 1, 2, 3, 4, 5. We want to do from 0, you go to 5, you go to 10, you go to, So an increment of 5. So that's exactly what we have over here. From 0, you go to 5, you go to 10, you go to 15. And of course, this one is ending at 19 typically. Is that okay? And that's why you don't see the 20 over here. But then if this was a 21, we're probably going to see the 20 showing up over here. All right. So I think our time is up and I'll leave it here for today. When we meet on Friday, I'll do a recap of this. If there are any questions, we discuss that. And also, whilst we wait till Friday, the videos are there. Kindly go and watch to just reinforce some of the things I was probably rushing on. And I believe you'll be fine. So thank you very much, Dr. Mills. Please, I'm done.
Okay, so you just stay there. So if anybody has any comment, questions, please let us hear you. You can raise your hand and then we'll call you. If anybody has any comment, questions, you can raise your hand and then we'll call you.